Hi, everyone. Join us. We're going to go ahead and talk about integrating 3D models and IoT data with Itwin and Azure Digital Twins. Hi, everyone. Welcome to the Deep Dive series on IoT Show. We're excited to have you today, and it's a special edition just because we have one of our top partners, Bentley Systems, who are here, who's going to help us go through this technical walkthrough of integrating 3D models and IoT data with Itwin and Azure Digital Twins. So I'm really excited again to have all of you here. If this is your first deep dive, welcome. Deep dives, we do these technical walkthroughs, really want to get into how you actually build something, go through the best practices, have a developer and an architect point of view, and we also have live Q&A. So if you're joining us live, feel free to ask questions. We're all going to be on chat, helping you out. I'll be focusing on Azure Digital Twins questions. Josh and Roop are going to be focusing on all of the iTwin questions and also Azure Digital Twins. So feel free to ask your questions in chat. And if you're viewing this on demand, don't worry. We do have IoT tech community. So if you have additional questions, at the end, we'll go through where you can reach out to us to continue asking your questions. All right, so as I mentioned before, I'm super happy to have Josh and Roop joining for Bentley Systems team. Bentley Systems is a software development company that supports professional needs for those who are responsible for creating and managing the world's infrastructure, including roadways, think of bridges, airports, skyscrapers, even power plants, and even utility networks. So I'm really excited to have a partner who is deep and knowledgeable about these different industries. So I'm going to go ahead and introduce Josh. Josh, do you want to give a little bit of what you do at Bentley?
Sure. Thanks, Pamela. So yeah, my name is Josh Schifter. I'm a software development manager at Bentley. My team is responsible for encouraging and fostering the developer ecosystem around iModel.js. That's our open source platform.
Happy to have you, Josh. And then we're also joined by Roop. Roop, do you give a little bit more of what you do at Bentley?
Yeah, thanks, Pamela. Yeah, so my name is Roop Saini, and I work with Josh on Josh's team. I'm a software engineer one, but I work on the outreach side for iModel.js. So I run a blog and also provide technical support to new developers who are getting used to the platform or have questions about it. So in that way, I'm able to produce content, make videos, and get the community started with their new projects. So that's my role, and I'm happy to be here.
Yeah, happy to have both of you here. My name is Pamela Cortez. I am your host for today. I sit on the Azure IoT team. So very similar to what Roop and Josh do at their companies, I do at Microsoft. So it's a little bit of cloud advocate, but also I help make the technical content to train folks. And also I have a specialty in embedded developers. So as an embedded developer myself, all about creating technical content to help with Azure RTOS or just connecting any device to the cloud. And so I'm excited to have all of you here. All right, let's go ahead and get started. So we're going to go ahead and look at what we're going to be doing the session. So we're going to jump to the agenda slide. And what we're going to start off with is we're going to go ahead and demo the application that combines 3D models, 2D maps, and a reality mesh into a single environment for visualization. After that, we're going to go ahead and do a walkthrough of the architecture that enables the application. So you're going to be able to see what products and services are we using, how does Azure Digital Twins fit into the picture, where does iTwin fit into the picture. So we'll walk through that, and we'll talk also about the best practices that we've noticed when building this application. We'll also show how we've mapped that IoT data into the assets within the digital twin. After that, we're going to show how to keep digital twins in step with engineering changes. And so we're going to go ahead, let's jump into the products and services that we're going to be showcasing in this deep dive. If this is your first time hearing about Azure Digital Twins and maybe your first time hearing about iTwin or Bentley systems, I really recommend checking out some of our IoT show episodes, and because those episodes really give kind of the high level of what we've been doing with our partner, Bentley, and also talks about Azure Digital Twins. Christian from the Azure Digital Twins team and myself actually recently just did a deep dive on Azure Digital Twins that talks about the updated capabilities. So recommend seeing that as well, because we did announce that we have a full, kind of a updated capabilities refresh of the public preview. We did that announcement at Build. So if you're interested in all of that information, check out those episodes before or right after this session. So high level, when you think about Azure Digital Twins, really think about how modeling and creating these digital representations of an environment, normally that could be really difficult. And that's where Azure Digital Twins comes into play. It really helps you model those environments and brings the digital twins to life in a scalable and secure manner. So think about how businesses can connect assets such as IoT devices and existing business systems to Azure Digital Twins to have that digital twins representation. So if you're interested in Azure Digital Twins, definitely check out those episodes. And we're going to be deep diving into this session, talking about how to work with Azure Digital Twins and the integration of iTwin. And if this is your first time hearing about iTwin, think of the Bentley iTwin platform and think of this iModel.js as an open source programming library to provide powerful capabilities for integrating 3D, 2D, reality data, and other sources to link IoT data for a single pane of glass visualization, analytics, simulation, so users can make effective decisions in a timely manner. So high level integrating iTwin platform with Azure Digital Twins and other Azure IoT services, which we'll cover in the architecture session or section of our deep dive. Think of that as a way for us to make it easier for developers and integrators and customers building digital twins of their infrastructure assets, which I'm excited for us to deep dive more into. So I'm going to go ahead. We have a lot of material to cover today. I'll answer questions in the chat, but I really think it'd be great to have Josh go ahead and start giving us a demo of the actual application and the scenario that we're going to be showcasing today.
Sure. Okay, so we're just going to get right into it. There's a lot of moving parts, so the easiest way to describe it to you is to show it to you working, and then we'll circle back and show all how it's all connected together. All right, so we're going to start this demo with this view of the town of Coffs Harbour. This is a town in eastern Australia. As you can see from the map, the Pacific Highway is the main road. It runs right through the center of the town. And this project here is to create a bypass for that town, to keep the traffic from going through it. We can fade out the transparency a little bit so we can see for the project better. You can see a roadway that bypasses the town. This model. This is a full 3D model that shows all the engineering data that was needed to plan and construct this model. I just want to point out this section here, which I think kind of gets that point across, which is, this section here. You can sort of see all the places where the roadway cuts through this set of hills here, and you can see where material has to be removed and added to keep the roadway at a reasonable grade, right? So this is kind of the reason why I want to show you this part is just to say, this is the full-blown, complete engineering quality 3D model at a really arbitrary level of detail. This model has pretty much everything you'd expect, including like guardrail levels and on ramps, off ramps, local streets. Let's over on the left side here, we have a kind of different breakdowns of the contents of the model. For example, these are the kind of the key assets. These are the important things that an operations team would care about. For example, there's bridges, tunnels, and roads. This model happens to have 6 bridges, well, 3 if you count a northbound and a southbound direction. Similar with tunnels and roads. Why don't we just expand those out? We could see you got different kinds of roadways. You've got local roadways. You've got on-ramps and off-ramps. All of these different assets are being monitored by our IoT sensors. So for example, if we click on one of the roads, maybe we could see, this road has traffic counter, vehicle counter on it, and also some traffic cameras. And then maybe let's look at one of the bridges. They've got they have vibration sensors on them. Just to, again, we're just monitoring the health of these assets. And then let's pick a tunnel. We did a little more work on the tunnels because that's kind of the key. That's kind of the centerpiece of the demo here. This tunnel has temperature sensors on it, air quality sensors, and again, the cameras. I guess a key point here is that the sensors themselves are modeled in the 3D model as physical items. They're affixed to the, for example, affixed to the side of the tunnel. But of course, the data, the observations of the real-time flow, that's not part of the engineering model. That is the next part. We're going to show how we can see that live data coming in. So I think, Roop, are you ready to show that?
Yeah, thanks, Josh. I'll go ahead and demo that bit. So over here to the right, you can see this globe icon. We click on that, and there's this functionality for turning on the live data. When we do that, we immediately start seeing some colors on our assets. So let's take a step back and see what that looks like for the model. So let me zoom into some of these bridges. So you can see the colors are changing. There's green, and then there's yellow, and then there seems to be some fluctuation between the colors. And what that is the overall health of these assets. And this is where ADT comes in. We use ADT to take all the sensor information for each individual asset, and we calculate the overall health for that asset. And that value then is used for assigning the color. So over here you can see how the health's fluctuating, and we can actually take a deeper dive. So let's take a look at one of these tunnels. So over here, these are the different sensors we have that Josh just described. And let's look at the air quality sensor, for example. So you can see the values over there, the CO and NO2 values. For example, the CO value, it's in the range of like about 2 parts per million. And you can see the values change in real time. So what this is actual real-time sensor data coming in that's hooked up to ADT, and it's giving us information for this asset. And this is just one of the sensors. So let's go ahead and take a look at temperature. So you can see the temperature value change. Now, something interesting that just happened, if you noticed, was that the temperature sensor turned yellow and the entire asset turned yellow. So that's just an example of how the sensors are used to calculate the overall health for the asset. Now, as soon as it turned back to green, we go back to the worst case scenario. In this case would be green because all the sensors are green. So that's what happens. That's how we calculate our overall health. So let's take a step back again. And so far we've seen the yellow and the green, which are both acceptable values. What happens when there's an actual crisis in the system? So Josh, do you want to go ahead and simulate a situation where things might go wrong?
Yep. Yep. I got the button going, so it should usually just takes a few seconds before it finds its way through.
All right. So code red in T1SB. T1SB, that's the tunnel one, southbound. And you have the option to go to the issue to see what's going on. So let's click on that. It zooms in, and then you can see all the different sensors. You can see the red sensor right here. Again, it assumes the worst case scenario. So this is the air quality sensor, and you can look at the CO value. It's at 8 parts per million, which is 2 to 3 times of what it was before. It's really high, and we have this camera right here, so maybe that could help us investigate what's going on site. So let's go ahead and click on this and see what kind of options we get. So let's do the show image, what this camera has captured. And oh wow, so as you can see, there's an accident. And what likely happened here is that because of the accident, there was a lot of congestion in the traffic. And since all these cars are stuck in the tunnel, there's the air quality drops immediately. And that's what's causing the issue. So at this point, there would be a functionality in the app in the future where you could turn open up the ventilation to let the air out, or it could be something that's automated. And yeah, so that kind of covers our use case. One thing here to note is that the camera right now, we just have it for the developers out there. We have it hooked up to an image. So we don't have real cameras on site right now, but this can potentially be added as a feature. So, okay.
Oh, Roop, just to ask a question, because you made a mention of the timing earlier. What is the latency? So I can imagine, the semi just got into an accident. Timing is really important here, especially to open up the vents. What is the latency that you're looking into from getting that data and having it show up here?
Right, that's a great question, Pamela, and I agree. It's very important that we get this data in the right time. So right now we have 10 seconds of delay for the information, but at the same time, that's because we are polling every 10 seconds for the information. The better mechanism for doing this, which is also an option, would be to do some sort of push. So every time there's an update on the ADT side and we get new sensor information, then we would update the information immediately. The app would get notified that, hey, there's new data, pull, and then that way we'll get a more immediate response. So that's the way it's set up right now, but it's got potential to improve. So that answers your question?
It does, and it also brings up another point of this is because you brought up what are some ways that you can improve. I kind of want to bring up that this sample, that application that you just built, the team built it in a couple weeks. So there's definitely elements that the team will share of where are some areas that maybe you guys will investigate and add later, or some things to think about if you're using this for your own applications.
Okay, we will think about that through the course of the demo as we look into technical details, and we'll give you the answer by the end, okay?
Okay, sounds great.
All right. Okay, so one more thing, speaking of time, is we got the live data coming in right now, so we know what happened in this moment, but what about the historic data? Are we keeping track of what's going on? If somebody stops monitoring the app and they need to look back in and see, what has happened in the time that's passed, we have this thing called, we have historic data, so we're actually capturing all that information. So let's click on historic data to see what kind of information we get. Okay, so over here you can see what happened to the tunnel. So you can see that the readings were normal, and then we had that crisis and the value spiked up. So that's how you can find out what's going on historically. And this is TSI, by the way, Time Series Insights. So the app is hooked up to a TSI instance on Azure, and then we're using the TSI, the UI components, and integrating them within the Itwin Viewer.
Okay, so yeah, this is a big diagram. It's got a lot of moving pieces to it. We're going to walk you through it. This shows how all the data flows throughout the whole system. So there's two data feeds here. Over at the top, we have the live data feed that shows how the data flows through Azure IoT Hub and Azure Digital Twins. And then at the bottom, we have the engineering data flow, which shows how this data is created, the 3D model is created, and how it eventually finds its way onto your web browser via the Itwin Viewer. Okay, so we're going to take it bit by bit here. So at the beginning, you have people using their I call them old school desktop apps like Civil 3D or AutoCAD even, or Smart Plant, Revit. Basically, there's a wide variety of formats that are supported. Users are working away on their desktop apps, making engineering changes, and then those changes are brought over into the iTwin world. So here's an example of one of those desktop apps. This is Bentley View. It's a live view. In this actual data was created in a Bentley product called Open Roads, and you can see here. This is the full engineering data for that shows the exact shape of the earth that was cut out and replaced, and in as much detail as you could possibly imagine. And then okay, so let's go back to the diagram and show. So here we show that how the data finds its way over into the cloud. So there's a set of conversion programs that we call bridges. Those bridges convert the data into a format we call iModel, which is a cloud-ready format. We have a quick just a view of the application that does the conversion. This is a desktop app called Itwin Synchronizer. You can run this locally. Here it is converting over that data. It runs very quickly for the most part. And once you've got it, the data is transferred into a cloud service that we call iModel Hub. iModel Hub keeps track not just of the data, but of all the changes that went into that data. So it is a full historical record of every change. And you could think of it, for our developers in the audience, think of it as GitHub for infrastructure data, right? So you can use this to track all of the changes and who made them and when they made them. And here's a screenshot of our portal that's showing it. This actually is showing the change sets that we committed, while we were preparing this demo. So there's, we first uploaded a pretty full-blown model because we're not 3D modelers, and then we made some changes to it and we committed those until we had the thing ready and we were ready to start using it for our demo. Okay, so that's that section, and that it talks about how, again, that's the engineering data flow that proceeds at the pace of engineering change, right? Think of it for developers. I always think of it as, code changes, right? You make a change, you make a pull request, review it, and it eventually ends up in the up in GitHub where everybody can look at it, right? Okay, so next section is how do we get it onto into your web browser, right? So we have a program called the Itwin Viewer, which is very extensible. You can use it in your own web page. You can design your own application around it. And let me just explain how it works. It communicates with an iModel.js backend, which serves out all that geometry that you saw that you could zoom in on and view. And it also integrates together different cloud services, data from lots of different cloud services, including reality data services. In this case, we showed you some Bing Maps integration. That's our background map. There's also terrain. We showed you the 3D terrain. All that is integrated together into the view that you see in the Itwin Viewer in your browser. Okay, I think that probably explains that part. And of course, I forgot a quick screenshot just to remind everybody. This is a Bentley product called Design Review that uses the Itwin Viewer, and it has lots of tools in it to do comparisons with different versions and to get really, really deep into all the engineering detail that you would need to do design review with a team of engineers.
And
Okay.
One thing to add here, Josh, so this is the same model that we just looked at in the old school application, and you can see how the Bing Maps and the reality data got pulled in. And design review is a great way to just test out and see how, what the data that was mapped in into the iModel Hub, what it looks like, give it like an initial look. And then from there on, you can use an Itwin Viewer to expand on this functionality and add whatever features you would like to add.
That's right. So yeah, so let's go back. Let's just quick summarize. I guess we already did. We saw the data flow all the way from the left to the right, all the way from the desktop onto the into the web browser. And but the next question is, how do we marry the two together? How do we get the live data in here, right? So the key piece to that is this section where we call it an exporter. Where what we're going to do in this section is we're going to essentially create the Azure Digital Twins instance based on the contents of the iModel. So remember that iModel is integrated together from lots of different engineering data sources, and that's really that model there knows everything that you need to know about this, and in this case, this roadway system. But of course, it doesn't know anything about what sensors are hooked up through the Azure IoT Hub. So we need to tell Azure Digital Twins how to do that. And so this is the first really key piece that was new for this project that we had to develop. So I'm going to get really in detail. I mean, they asked me to go as detailed as I could. So I'm going to share my screen now, and I'm going to show you how we did that. All right, so here we are. I'm going to show you the application, the exporter application that converts data from the iModel and creates the instances in Azure Digital Twins. I'm going to start with the data format. This is a DTDL, Digital Twins Definition Language. It's a superset of JSON. This JSON you see here, there's basically two different kinds of data we need. We need the type data, and then we need the instance data. I think that's probably self-explanatory to most people listening. So the type data or metadata describes what all the different types of data that we want to convert over. So for example, this one here shows what a sensor looks like. A sensor has a bunch of properties like a device ID, to identify it. It has an observes property. That's the asset that's being observed, like maybe it's a bridge or a tunnel, right? Then it has the way we modeled this, a sensor could observe up to 2 readings. So we have an observation label, say CO or NO2, and then a unit like parts per million, parts per billion, and then the value, what that live value is. Of course, we don't know what the live value is when we're running this exporter, but we're leaving a placeholder so we can fill it in later, right? Okay, the next things here you'll see are the types for things like bridges and ramps and road segments and things like that. Okay, I'm going to show you how we actually now. The next step is how we actually create that DTDL. This is the program. This is the exporter program that we wrote. So let's just jump down here. We're on line 124. We're looking at a method called create physical asset types. So what this is doing here is the first part is a SQL query that we're using to interrogate the iModel. We didn't hardwire what all those different asset types are, like the bridges and the tunnels. This program doesn't know ahead of time that those exist, but it does know that they're a subclass of something called a roadway composition item, a road network composition item, I should say. And so this query will get us back all of those different types. And then you can see this right here. We're actually going to build. This is the actual string, the class name. This is the word bridge or tunnel or road, right? So this is the code that creates that DTDL that we showed a moment ago, right? The type DTDL. Okay, so the next section is the instance, the instances. So this is a file that kind of combines together. I know I put the JSON prefix. It's not real JSON because we interjected some explanatory text in here. But each one of these bits is a JSON patch that has the data for one asset or one sensor, right? That was all extracted out of that iModel. Each one has a unique identifier. Here you see here, this is that tunnel 1 southbound. That's always the first one that seems to come up. Here's the different road segments, bridges, and I think if we go down to the bottom, yeah, so here are all the sensors. There's a whole bunch of sensors. This one, there's that tunnel 1 southbound. Tunnel 1 southbound interior air sensor, right? Air quality sensor. And these are all the properties for it. You can see here's the observations. It's observing carbon monoxide and nitrogen dioxide, right? And they're all in here. So next, I'm going to show you the code that we used. We're going to jump back to the source code and show you how we generated this file. So that's over here. We scroll down a little bit. Yeah, we're on line 145 here. We're going to query. Let me show. No, sorry, 167. We're querying the iModel again, but this time we're looking for sensors. We're looking for those sensors that are observing an element. So those are the ones that are important, not the ones that are just kind of sitting there that maybe haven't been hooked up yet or haven't been assigned yet. So if you're observing an element, we want to query you, and for you, we want to generate this. We want to generate one of those JSON patches. I'm going to scroll all the way down here, just to point out here that you see here's where we're getting the observation, the label, and the unit. That's that CO and the parts per million. But of course, we don't have the value, right? So it's we just put a placeholder in there, and that there is waiting then for the value to come in live from IoT Hub. So that finishes up that part. What I showed you was how the exporter works, which is the part that brings data from the iModel and creates the ADT instance. And that's part of a bigger section. Let's just jump back a little bit again, right? This is the whole flow of engineering data. Now it includes, for the first time, it includes this section that I just showed, the exporter that brings us, that sort of invigorates and creates this Azure Digital Twins. Okay, so finally, Roop's going to come back. Roop's going to talk more about the, again, about how the live data transitions.
I'm ready. Thank you, Josh. So I'm going to transition over to the next slide. If you can see over here, we have the architecture for how the live sensor data is coming in. And you will see that it starts all the way from the source of the sensor data, where that's coming from. So we didn't actually go in Australia to Coffs Harbour to hook up some sensors on the road. We actually used a simulation service. Like Pamela mentioned, we only had 2 weeks to prepare this. So we worked with all the resources we could get at the time. Now, before we dive into this workflow on top, I want to just take a step back to where Josh was talking about the ADT types. So he showed the model. What happens over here is we use this DTDL and create an instance of ADT. So what I have here is a Postman query or our actual ADT instance. So you can see over here, Coffs Harbour API WUS2. Now this is an actual ADT instance that we created on Azure. And then what this particular API does is it gets all the models that are loaded in this instance. So over here you can see we upload our DTDL, and you can see the actual, the same types that Josh was showing. We have the sensor here, then we have our bridge, and the ramps. So all the different types that we saw in our demo, we can see over here. And the other piece here is Josh showed the actual instance data, for example, a particular sensor. So you can see this is how you can query an actual instance or a node with an ADT. For example, T1SB, this is T1, Tunnel 1 southbound interior air 1. That's the unique ID for that sensor. And you can see over here the actual instance data. So you can see some values over here, the observation value for the CO, and which, if you remember, it was around the scale of 1 to 2, and then you have the NO2 value as well. And you can also see observes, and this is the tunnel that it's observing, T1 southbound.
Hey, Roop. I noticed the last time that we were looking at the numbers, it was around 8 or 9, and now the numbers are different. Do you want to explain what happened?
Actually, Pamela, let me jump in there. So remember, I triggered that alert, and after we were done with the demo, I actually turned it back off. So that's why you see the numbers are back down there. Yeah.
Yeah, thanks, Josh. And what's perfect is that kind of segues me to the next topic. So let's go back to our workflow over here. So we saw that we have the ADT instance up and running now. So we have the DTDL loaded. We have some instance data in there as well. Then how are we actually getting those sensor values, and how were you able to control them, Josh? So that's the question I want to answer for the audience now. So for that, we have a simulation service. I'm going to go ahead and talk about how we're getting the sensor data into our ADT instance. So let's take a look at the workflow here. So this is this device simulation service on Azure, and we have used this to create 44 different devices, and then each device has been defined in such a way where we can give you the high value, the low value, and we can change those based on if you want to spike the sensor like we did in our crisis situation. And these sensors are then linked into an IoT Hub instance, which you can see right here. And if you look under the IoT devices blade, over here you can see the list of all the devices, and you can see the unique IDs for each device. Now this is what maps all the devices from the simulation service into the IoT Hub. And this is the same device ID that's also contained within the iModel that the exporter was using to export out our data into the instance, into the node instance, as we saw here. Okay, so once we have this information in the IoT Hub, we have devices getting the telemetry information, but how exactly does it go into ADT? So for that, what we have is this Azure function. Now, this Azure function is responsible for, and this is actually one of the key pieces of our architecture here. What it does is it takes all this telemetry information from all the different sensors, and then you can introduce your own custom logic in ADT to calculate the values for the high-level components. So, for example, we were getting the sensor values for the first tunnel. Let's just take a look at that. We have all these sensors, and then somehow we're computing the overall health for this asset. All that logic, the computation happens within that Azure function. Mm-hmm. And then this is able to inform ADT what the meaning of those values. So let's go ahead and look at the actual code. So this is the code for our Azure function. Before we get into any of the actual detailed code, I want to show you the local settings. So this is just a template of how you create an Azure function. I believe I use an extension, a VS Code extension, to create this. And what we have here is the event hub connection. So this is the endpoint connection string for our IoT Hub instance. And that's what gives us the telemetry of the sensors. So when we get new CO and NO2 values, this is the function where we get them. And we get the IoT Hub device ID, which is the one I just showed you on the IoT Hub blade, the devices blade. And then we also get the message data, and the message body contains the actual telemetry of the CO NO2 values or temperature values. So then we go into this function called process data for device. And I'm just going to very briefly go over this. What happens is we get our device ID, and we query within ADT. So this is our first ADT query. The way we do that is we select star from Digital Twins, and we give it an alias T, where this is the actual predicate for the query, where the model type, that is the actual instance type, is going to be sensor one. So it's a sensor we're looking for. It could be a sensor, bridge. We need to tell ADT what we're looking for. So we're looking for a sensor in this case, and we want a sensor where the device ID is equal to the value that's coming in. So that maps the instance data that we loaded in our post with the actual value that's coming in from the IoT Hub and the sensor simulation. So then we go ahead and check to see which kind of temperature, air quality, vehicle, or the deflection sensor. And then we just get those values. Some sensors can have 2 values, some can have 1. For example, temperature only has 1, but air quality has CO and NO2, 2 values. So we just figure out what kind of observation values we're getting back. And we generate this patch for the sensor. This is what we actually use to update the values. And it looks very similar to what we saw in our ADT instance upload code that Josh showed. So you have your observation value 1 and observation value 2, and value 1, value 2 that we're getting from our simulation service. We punch those in here. And then we go ahead and update that ADT instance, or update that the node in ADT. And then the way we identify a node in ADT is we use the DT ID, which is, again, the unique ID that we saw here, T1, SP, int, air 1. So that's how we are actually identifying each individual node in our ADT instance. So once we update this, okay, so we got one sensor data, one sensor value, and we updated that. But this is a point where you would wonder, hey, that worst case scenario is that when, for example, when our sensor turned red, what if this is the sensor with the bad value, or the value that we don't want to see? How do we update the higher level component, such as that whole tunnel? So that's where we call this function called update higher level twin. We take in the DTID. Now, if you look at this DTID, what this is the observed node ID. So what this sensor is observing. So which asset, for example, tunnel in this case, is this node observing, and then it can see the unique ID for that tunnel, which in this case is going to be T1SP. And then we do another query with ADT. We just get, again, all the sensors where the node that it's observing is this node ID, T1SP, for example, the first tunnel. That'll give us all the sensors for that tunnel. So all of these sensors, you'll get all their current data in ADT. So then once we have all the values for all these sensors, what we do is we go ahead and basically run this logic that checks to see if the value that we got is the worst case scenario, or it's less than that. If it's less than the previous health that we had computed, then it doesn't do anything. It just keeps the health the way it was. But if it's more, then we have to update that value for the computed health for that asset, or for that tunnel, as an example. So over here, you can see that we use the DTID again to get our tunnel, and then we get our computed health, and we get that max percentage that we're getting from this computation. And we generate a patch again for this value, and then we update our the same update code, that tunnel with that patch document. And that's what updates our data and gives us our overall health. And this is where ADT really shines, is that you can introduce any custom logic you want that fits your purpose for your digital twin, and it can really do anything that needs to be computed, from raw sensor values into something that's meaningful for a bigger use case for a project. So that covers the ADT code. And we're going to go back to our slides here.
And Roop, while we're going back to the slides, I like how you mentioned that there is a VS Code extension, and that we do have tooling support for Azure Digital Twins, even through the CLI. We have an extension for the new updated capabilities for Azure Digital Twins, so you can check out the tooling support that we have.
Okay, so we went from sensor data into our ADT instance. Now the question is, how do we get those values that we just punched in into our Itwin Viewer, into our app? So let's take a quick look at that code. And I just want to share that a little bit, just so developers out there. By the way, we're going to share all the sample code, so I want them to be able to reference it and use it for their own use case. So this is just the glue that kind of connects our ADT instance to our Itwin app. So this is that call here. If you look at this,
and Roop, I just want to point out, this is the third big piece, right? We talked about how we create the instance, the Azure instance. We talked about how we update it, and now we're talking about the third big piece, which is this is the customization that we did to the viewer. the Itwin Viewer.
Right, and this is finally like all the hard work we put into getting our data out there. This is finally bringing it in full circle into our app. What we're doing here is we're using a proxy server within our Web Express server here, and we can over here you see the actual ADT instance URL. So if you look at this, what we're saying is that anytime we send a request to this to our deployed resource, and we get a routing of digital twins. Then if we get a routing for query, models, digital twins, or event routes, then we take that request and replace the target from that IP that we saw to our ADT instance. So for example, in this case, we're passing in digital twins as the route, and then we pass in the DTID for each individual node whenever you click on one, like a sensor or a tunnel. Then you get it takes that extension, it takes that route, and it knows that that's what you're calling into that proxy, and then replaces the target. And that's how we're able to forward our requests to ADT. So that gives us our data from our ADT instance into our Itwin Viewer. Now the last piece is how do we go from the ADT instance to time series insights first, and then time series insights to our Itwin Viewer. So for ADT to TSI, what we do for that is, let's go into our Azure portal here, and we create an event hub. So there's great documentation on the ADT website for this. How do you hook it up to event hubs? But we basically hooked up our ADT instance with a custom event hub I created on Azure portal, and we just gave it all the policies for reading. And what this does is anytime there's a write event on ADT, when we update the sensor or the asset values, and it just captures those events, but it doesn't save those events, it just captures them. And that's where TSI comes in. So this is our TSI instance. And if you look at the event sources, you can configure different event sources in any TSI instance, and you will see that Coffs Harbor events is the same event hub. You can see the event hub name that we created with our ADT instance. So that's how it ties into TSI. And we can actually open this TSI instance on the web, and over here you can see the actual values for all the different nodes within ADT. The way we are searching for this predicate is we look for the value for the patch that we're getting in when we write into ADT, and then there are different ways in which you can classify this information. You can do it through events, IDs, but the subject is what we were looking for, and that gives us all our nodes. So for example, these are all the assets, and you can see their health, overall health, and you can see that the one that spiked over here. So yeah, so that's how we get our values into from ADT to TSI. Now the last step, and we're almost home, is how do we go from TSI to our Itwin Viewer, which is the historic values that we saw for our asset right here. The way we do that, it's very similar to the way we set up the code for ADT. We have this time series class here, and the way you can do that is use this TSI client library. It's for TypeScript, JavaScript and TypeScript that you can get. And then you create an aggregate expression. And this is very similar to what we just saw in the TSI Explorer Online. You have your subject, this, and then this is the DTID, for example, T1SV that we pass in. And for this function, you can get the history for anything as long as you pass in the DTID. And then you look for the patch.value. And yeah, and then we just configure stuff like color and what the label should say. And then we get our values, and this is the actual request that gets our values. And then we just display the actual graph. It's just a div for the graph, and we render it by calling this function. And that updates the values, or actually, no, this function, my bad. And that's how you update the values within the TSI graph. So as you can see, we can change around and check out a bunch of different assets. We can even do sensors, not cameras, but we can do temperature sensor, for example. Okay, so that covers overall what the architecture of how we got our live data coming in from the sensor simulation into our ADT instance, into our Itwin Viewer, and then also the engineering data, which went from the old school applications, as Josh mentioned, into brand new, the iModel Hub technology, which takes it all the way into the Itwin Viewer, which we were able to extend and then bring all the pieces together. So yeah, that summarizes everything. And do you have questions, Pamela?
Well, that was great, Josh and Roop. Thank you for bringing a full technical walkthrough, or doing a full technical walkthrough of your iTwin plus Azure Digital Twins application and integration. It was nice to see Azure Digital Twins in a real world scenario, instead of just saying, this is how you build with Azure Digital Twins. So this was really, really awesome to see. So I have a couple of questions, because I know I gave you a really loaded question in the beginning when you were showing that demo, and that was, it sounds like the team made this sample in a couple of weeks. Is that right?
Oh yeah. We literally had 2 weeks from start to finish. Now I'm not going to say we didn't have any help. We did.
It was right? You and Roop.
But we did, but surprisingly less help than you might think, given the time frame. The technology was actually pretty easy to work with. Yeah.
Yeah, and one thing I'd like to add here is that with iModel.js, we've been doing a lot of hackathons over the last year, where we do like week-long sessions and we come up with proof of concepts, and that's kind of been our way to kickstart new projects. And all that experience came into play when this challenge was given to us. We were like, you know what, let's do a hackathon. So that's why we decided on the 2-week deadline. Yeah. We didn't, that's not something we had planned intentionally, that in 2 weeks we got to do this. It was more like, let's do a hackathon about it, and then let's see what happens, and everything came together.
And I love you mentioned you did a hackathon, just because I'm seeing more and more companies doing that, where they kind of they bring in these hackathon events kind of as training initiatives. I don't know if your team uses this as training initiatives, but also just to test out new products and services that teams haven't worked with before. So that's great that you mentioned that kind of got started because of a hackathon. So you started a couple weeks ago, or had a couple weeks building this sample. Was this your first experience working with Azure Digital Twins, or have you worked with the public preview that I believe we went public preview over a year ago? Did you work with that one, or is this your first experience with it?
Got to admit, I did not know anything about Azure Digital Twins before we started. I think about 2 weeks before was when I saw the first email, and they said, we're going to do this project. And, we did some research, and yeah, we hit the ground running for sure.
Love it. And to go back to that little question that I asked in the beginning was, what would you think your team would have done differently, or what would you recommend for anyone who wants to take this sample, learn from it, use it, work with your team? What would you recommend on some changes? Like, for example, I saw in the architectural diagram that the team showed, you used Bing Maps instead of Azure Maps. And I'm kind of interested in that thought process of using Bing Maps versus Azure Maps, which both you could use. So examples like that.
This one's really easy. I'll take this one. This was okay. Because we had done previous hackathons, and we had it set up that way already. So we didn't have to do any work. We just had to put the little switch that turns it on, and it was there. So
nice.
Yeah. And believe it or not, while Josh was talking and you asked that question, I actually made a list of some things that we would probably do. So I have it right here. So as you mentioned, the whole idea that what's the latency for the sensor data coming in, and time is actually pretty key for a solution like this, especially in emergency situations. So one idea we had that we want to implement in the future is automating that response of, for example, we have an API for opening the ventilation and letting the poisonous air out of the tunnel. So we want to automate that response. That will be one thing, again, for the time. Another thing to improve the time would be, instead of the pull mechanism where we're pulling for data every 10 seconds, we would push. So every time ADT gets a new sensor information, or we can even compute, like we saw, you can add a lot of custom logic in ADT. So within the Azure function, we can, for example, add some sort of extra notification system, and whatever can get the data the fastest. So we would pursue that. Then there's this whole thing of how Josh mentioned that there's the IoT devices within the model. So that's one of our architects. He actually made a schema, the IoT schema. And that's something, that was the first time we invented the schema like in 2 weeks, but he wanted to standardize it. So right now he's going to standardize the schema and it's going to be available. We call these BIS schemas, which are standardized schemas that multiple, since all this engineering data is coming from multiple sources, it standardizes it into kind of like a single format that is that can be understood by multiple applications. So we want to standardize that schema, and when we get that standard, we can apply that to the exporter tool that Josh was talking about. So now the TDL production would be automatic. We want to make it seamless as possible. And making things seamless, we actually had a lot of people request the source code for the solution and how to take the different steps. They love the demo. So we're going to make the sample code public. And the idea is, and this channel line video has actually been a great opportunity to talk about it. We can point people to this, and they can, look at the sample code and go back and forth and kind of understand how to bring this together. So you want to make it as seamless as possible to get up and running, and hopefully, get this and make it usable.
Well, when we get to the resource slide, we'll talk about where you could find that source code. Before we jump into that, I kind of want to leave it like an open question on, any developer who's starting to work with Azure Digital Twins. What is the top feedback that you would give to that particular developer or even an architect when they're thinking about designing or developing with Azure Digital Twins? Like, what is your top thing that that you would like to share with folks? Like, it could be tooling, it could be resources, it could be, hey, it took me a little bit longer to understand this part and I found this really helpful, anything.
So I would say, and Josh, please add your comments as well, but I would say the thing that this is kind of like what drove us in the hackathon was getting those early successes, because every time we got some success, we were like, oh, wow, we can see something happen. And I would recommend that, that would be the workflow people pursue. So, for example, I love the simulation service and the fact that you can just produce it. You don't have to hook up actual sensors. You can use a simulation service and start getting data into ADT. And then you can hook it up to your app. And that's a very quick success you can see. Another idea is to directly first talk to IoT Hub, start getting the sensor information in, and then move it to ADT as you start calculating information for the higher level assets. So getting that early success in, I think, is key, because it kind of opens up that possibility of what you can do next. And as far as resources, there's actually a lot of great resources out there. Some things require a lot of steps, like hooking up the event hub to ADT and then do TSI, and it can seem overwhelming when you look at the documentation page. But once you go through it, it's actually not that bad, and things come together. So I would say not taking too much pressure and just kind of trusting the process is helpful.
Don't try to do it in 2 weeks. See, that was one thing for sure. Whoa, but we did it. So
yeah,
I mean,
we did stay up late a few times, just to be fair. It wasn't that.
Yeah.
I mean, everything you guys got accomplished in a short amount of time. That's why I'm so excited that you actually are here to do this technical walkthrough and show what you were able to accomplish in such a short amount of time, because it's super helpful to, I know, at least for building IoT applications and everything else, proof of concept can take a really long time for a lot of companies, depending on the different applications. So it's nice that you can get up and running pretty fast. I know, Roop, you've mentioned a couple times the device simulator. So we do have that service. I know a lot of our tutorials have mentioned just kind of a example code on simulating data. But it's nice if you want to simulate tons and tons of data or devices to be able to use that service. So
Right.
Great call out. Yeah.
And I'm glad you mentioned that, because you can also do stress tests, which we did as well as how much sensor data can you pump in and see how the app reacts, which I think is also useful. Yeah,
you don't have to create a bunch of example code just to have tons and tons of devices. It's kind of a nice click and go.
Exactly. Like, it reminds me of one of the hackathons we had, presence sensors, and in order to test that, we kept having to go back there and stick hands in front of the sensor so we can get some data. You don't have to do that.
That's always my favorite. You have a device with a temperature sensor. You're like trying to change the humidity on it by breathing on it to change the Yes, it's just nice to work with simulated data when building applications. So always nice.
Yeah.
Awesome. Well, thank you so much again, Josh and Roop, for taking us through this. We're going to go ahead and jump into the resource slide. And I'm going to talk about some ways that you can reach us, become a part of the community, and then how you can find the source code. All right, so the resources to get started. So we have, before jumping into where you can get the source code, you're already at the IoT show, so you already know about the IoT show, but we host a lot of different formats, including these deep dives, which are really meant to be these community stand-up events where you get a really, as the name implies, a deep dive and ask questions directly with us, the engineers, and the folks actually building these products and coming up with the samples. So it's a great way to get in touch with us and ask questions live while learning something new. And we also have what we call the IoT Show Classics. Those are kind of the snack bite versions of videos that we do, just so you can hear the latest announcements, maybe have a partner spotlight, be inspired by a new project. And so we definitely have those different formats, and we're growing the channel. So stay tuned in what we're doing there. And then we have the IoT tech community. If you're not part of this community, that's where we are posting new blog posts. It's really meant for, different developers, architects, and we have different conversation spaces. So if you're like me, an embedded developer, we have a space for you that's about devices, where we talk about the latest things, give example projects, talk about features that might help with your application, new features from products that might help with you connecting your device to the cloud. But we also have all of these other conversation spaces because IoT is super broad. So it's nice to find different communities where you can, talk about maybe you just had a home automation system that you did in your house that you want to share with folks. We have a conversation space for makers. Or if you're working with Azure Sphere, we have a conversation space there too. So check that out and share your projects there. So if you want to get started with what you saw here or learn more about the iModel.js, we do have iModel.js.org site where you can actually learn more about iModel.js. Again, that URL is www.iModel.js.org, and you can go ahead and learn more there. And then if you are interested, there is a blog meant for the iModel.js. So there's new posts that you can check out. It sounds like Roop may or may not do a post about this video and his process, Josh's and his process about it, or at least giving an update. And then we have the link to the actual source code. So the sample itself that you're seeing right here, you can actually find that on GitHub. That link is right there. I'll make sure that this link is added to the chat and then in the description, because sometimes it's hard to type in some of these URLs. And then if you have technical questions, let's say you have a question about Azure Digital Twins, or maybe you have a question about time series insights, you can actually ask those questions on Microsoft Q&A. Myself and others, we have a full crew who is monitoring Microsoft Q&A. Think of it as Stack Overflow. So if you have a technical question, go ahead, you can go to Stack Overflow, but you can also go to Microsoft Q&A. We have engineers and both channels. So go ahead and check those out. So thanks again for joining us. Thanks for everyone who's asked questions and everyone who's viewing on demand. And special thanks for Josh and Roop for giving this big deep dive. I know that was a lot of information because you accomplished a lot in a couple weeks. So thanks again. We really enjoyed having you here. All right. Thanks, everyone. I hope everyone has a great day.